So we have understood and practically demonstrated the power of one-way ANOVA test with respect to the continuous type target variable and categorical type features, and it is useful to the core. So it's going to help you a lot because it will, we have demonstrated one example where we were able to select a feature out of three features, which makes more sense than randomly taking a feature or with the gut feeling taking the feature. More than that, if you go with statistical significance, it yields a better results. So that's the reason. So and our one-way ANOVA test holds a huge amount of power. You have to unleash the power to understand, to use it better in your project. So now that's okay. It's all fine. You got the clarity how it works, how to use it. But do you know how exactly works? Do you know what happens behind the doors with respect to the one-way ANOVA test? What you have seen is the output. The probability value you have seen is, you have seen the f statistic, observed f score or f test, f value, and you have compared with the p value and level of significance, and you have come to a conclusion. But under the hood, inside the box, what exactly happens? That's what I'm gonna open it now. So I will be demystifying the one-way ANOVA F test, and I will be opening the black box to understand what exactly happens behind the closed doors. So as usual, let's begin with the same example. We'll take up the same example, nothing much to be changed. So step one, define the null hypothesis and alternative hypothesis. Uh, Null hypothesis, as usual, there is no significant difference in the means of the groups. Alternative hypothesis, there is a significant difference in the means of the groups. Then let's calculate the observed F statistic. So again, to calculate the observed F statistic, we'll use F mean square between divided by mean square within. So we have discussed a lot of times regarding this formula, and MS between can be calculated using this, and DF between is equals to K minus 1. So number of categories minus 1, and MS within and DF within is number of sample size minus number of categories in that variable. So that's what K is number of categories or groups, and N is total number of observation or total sample size. Okay, so that's how we calculate the observed F statistic. So let's look into the code once. So as usual, we have imported the required libraries and modules. Then this is our data frame. If you want to see, I'm gonna show you the data frame. This was the same data frame that we have used earlier, and this is the data frame. So product category, purchase amount, customer satisfaction, shipping speed, the same data set, nothing much, no change. So now I have used the stats method to calculate the F value because that's what I want. So observed F value I have calculated specifically. Here I'm gonna use only one relation. I just want to test one relation which is between product category and purchase amount, and these are the two I'm gonna take up. Nothing else. So observed p-value I have calculated between the purchase amount and then product category. So as I have a purchase amount and I have a group 1 is electronics, and purchase amount, and group 2 in product category is clothing, and purchase amount with respect to group 3 in product category, which is books. And I have used all three groups, and I gave it required arguments to the f underscore one way, and with this I got the uh, observed f value. So if you want to see observed f value, I'm going to give you, and this is 1.20769. That's what the observed f value, and that's what we got here too. You see that f value is 1.2076, and we have marked it correct. Now let's once observed f value is done, now let's move on to the most important step, which happens behind the closed doors. Till now whatever we have seen is can be visible, can be seen, it's all which is floating on the water, which is the tip of the iceberg. So the root of the iceberg can be seen, and that's what we are going to unleash, that's what we are going to unravel, that's what we are going to mine it. So let's simulate the sampling distribution. This is what the core of everything. This is what the heart of everything. So let's simulate the a sampling distribution. So let's permute the group labels while keeping the feature values intact. Calculate the F statistic for each permuted data set and repeat this process multiple times to create a sampling distribution of the F statistic, and that's what is the most important step here. So I have taken n permutations, which are 1000. That means I'm going to create 1000 resample. For each resample I will calculate the F statistic, and I will plot the sampling distribution. Okay, so if you want to see the permuted F value, okay, F statistics and permuted labels, and let me print it, and if you want to see, it's gonna take some time. Let's open permuted labels. Yep, here it is. You got that. It's not one or two, it's thousands and thousands. It's thousand. You'll have 1000 samples, and this is that. And you see that, you know, you got every time these are different permutations. It's not one, there's a different permutations of books, clothing, clothing, electronics, electronics, books, clothing, books, electronics, and it will be repeated, and it will make thousand and thousand. It will make 1000 resamples, and for each resample it's going to calculate F statistic, and that's how it works. So let me remove this, it's no more required for us, it's just to show it to you. Okay, so that's what, and you have to calculate no f permuted f value for the each resample. Okay, f value for each resample, and that's what f statistic. And once you calculate f statistic, then you can plot it, and that's what I have did it. And let me execute this to show you. And here is our sampling distribution of the f statistic, and this is how it looks. So total 1000 resamples, and the statistic with around 1 or 1.1021, that's maybe 0.8, 0.9, has been repeated closer to the 580 times, and this one has very high probability of getting, whereas if you move ahead, 1.2 has a very less probable, not very less, has a lesser probability than compared to the zero point 0.8, and 2.5 is medium, 5.0, 7.5 till 5, it's okay. They have a good amount of probability, but as you move right towards 5.0 and right away from the 5.0, the probability is falling down, because the frequency of getting that F statistic is reduced. Okay, so that's what is most important, because from this your probability will be calculated. From this your rejection region or acceptance region will be made, and from this sampling distribution your critical value will be selected. From this you will get a significant alpha value, significance level, and you can compare. So this is the heart of everything what we do with statistical significance test. A sampling distribution is heart of a sampling, a heart of a statistical significance test, and that's what is in front of you. So this is what I said. This is what I meant when I said I am gonna open the black box. Okay, let's move ahead to the next step. Okay, but before that, what I'm gonna do is, so this is what we got with this, with obviously the degrees of freedom that we got here is 2 and 6, correct? With the 2 degrees of freedom for specifically these two, product category and purchase amount. Okay, so with 2 degrees of freedom, let's see how actually it looks. So with 2 degrees of freedom and 6 degrees of freedom, this is degrees of freedom between and degrees of freedom within, and this is how it looks. See, exactly we got the similar distribution. This is default distributions which are made from the software, but when I use my sample and I have created a sampling distribution, it was by and large similar. You see that? Anyway, I will simulate this thing also. Just wait for a moment. Okay, so let me get back to the step 4. So now it's time to calculate the p-value. Then compare the observed F statistic with the sampling distribution to determine its position, and calculate the proportion of F statistics that are greater than or equal to the observed F statistic. So the p-value is nothing but the probability of obtaining an F statistic as extreme as the observed F statistic. So assuming the null hypothesis is true. So this is what the sampling distribution, I got it for the respective sample that we have used, and here you can see your observed statistic is 1.21. It's 1.207. So let's make it to the 1.21, and this one has a pretty medium level of probability of getting this value. Okay, so with that itself I can tell the level of significance between these two. However, let's follow the procedure. So okay, now let's determine the statistical significance also, because we are going to wrap this up with one animation. So that's the reason. Let's determine the statistical significance. I hope you got the main point. So now let's compare the p-value with a predetermined significance level. So I have taken a significance level of 0.05. so now 0.05 probability would be where? By and large, you tell me. It could be here, somewhere here. So this region is my rejection region. This region is my rejection region, because you can see that you have the frequency. So frequency 600 divided by 1000, because that's the total number of imputations, that's the total number of iterations. So probability of getting 0.5 or 0.6 F statistic is closer to the 0.6 percentage, closer to that. Okay, so when it comes to getting, when I say 0.05, obviously it could be somewhere here when you have 5. So that's the reason your rejection region may start from here to here. Okay, so obviously when we compare the p-value of this, the p-value of 1.21 is 200. It could be 20. It's a 0.2. It's 0.2. So obviously it's not exactly 0.2. It would be closer to that. Maybe we'll get around it will get the value which is closer to that. Let's see what value we get it, but still I'm just saying. So roughly I'm giving that value, because by just looking at the sampling distribution. That's why I always say, if you understand sampling distribution, whatever you're doing with statistical significance test makes a lot of sense, or else it's completely black box. Anyway, so next, if the p-value of the observed F statistic is less than the significance level, reject the null hypothesis and conclude that there is a significant difference in the means of the groups. But if you see, just here is my statistical significance, here is my level of significance, and here is my the probability. You see that this is the probability and this is that. So obviously my p-value is greater than level of significance. I can simply tell from here. So what I did is, it's kind of reverse engineering. Now I plotted this graph. This is the now default graph from the software. So this is the default software graph of F statistic distribution with numerator degrees of freedom of 2 and denominator degrees of freedom 6 with a right tail, and with the level of significance 0.05, and this is my rejection region. You can clearly see this is my rejection region, which is F. If we put it into critical value, it's 5.143. Now I'm gonna put our graph, our sampling distribution on top of this to make more sense what exactly happens. Okay, so that's what is my rejection region, and I brought down the sampling distribution of F statistic that I have created for our sample, and exactly it takes the shape of this. You see that? Exactly, it takes the shape of it, and this is my rejection region. As whatever I have said before, without using this animation, it's getting correct now. So this is my observed statistic, it's here. So when I see product category and purchase amount, my F value observed statistic is 1.21, exactly correct. Then P value, I said it would be 0.2, but it's 0.36. You see that? It's 0.36. It's closer. It's 0.36 because whatever I have said is maybe for one, it's closer to the 2. That's 0.2. But when it comes to 1.27, it could be somewhere here. So it's here. So 1.36. So if you just look at the probability, so this is 0.05 and this is 0.36. It's clearly my p-value is greater than that. So I'm gonna, I will, I fail to reject the null hypothesis. On the other hand, if you just go with the F values, F value is 1.207 here, and my F critical value is 5.143. It's clear, it's crystal clear that my observed F value is not falling in the rejection region. Then what does it mean? I failed to reject null hypothesis. What does it mean? There is no significant relationship between product category and purchase amount. This is what happens inside the black box.